I know, it's been a while, but I'm back with something that's been on my mind. A lot of us think we need to be hardcore developers or professional coders to master threat hunting. Honestly, we don't. But having basic scripting skills paired with regex and visualization, that changes everything. We can prepare the data, automate boring tasks, and build quick mini tools to hunt better and hunt faster. We don't even need fancy tools to get started. Basic Linux command and utilities are more than enough. Of course, Linux. The second we open the terminal, boom, Mr. Robot. Hi, this is Mesam Slahi. Welcome back to another episode of Cyber Threat Hunt 101. Don't forget to subscribe, hit that bell, and follow me. I practice, test, learn in public, and share what actually works daily and free. In the last episodes, we covered a bunch of data analysis techniques, different benefits, different uses, but they all shared one prerequisite: solid data preparation. Raw data is messy, noisy, incomplete, and sometimes misleading. Before diving into analysis, clean, validate, and transform it into the desired format. Data preparation is all about getting information ready, whether for AI model or manual threat hunts. First, we collect data from everywhere we can: logs, network traffic, threat intel feeds, basically anything that helps us understand what's happening in our digital wonderland. Here is the catch. One small mistake in the data can mess up the whole hunt. That's why data validation matters, to ensure what we collect is accurate, complete, and free of errors. What's next if it's not? Then we miss indicators or waste time chasing the false leads. To fix the errors, patch the gaps, and remove the junk, we need data cleaning and reduction, which improves the quality and size of our dataset. That's critical when we collect the data from different sources. Data integration is where we consolidate everything into one unified view, either from the same source over time or different sources with totally different formats and structures. Then we polish the data into the right format, which forms the foundation of analytics, machine learning, and detection tools to perform at their best. That's data transformation, reshaping data into the consistent format, whether before or during integration. The more data we integrate, the more complex things get. To keep the chaos in check, we could label each piece of data with descriptive tags, adding context and meaning. Building on that, data enrichment adds extra context from external sources, like threat intel feeds or even our own historical data, so we can make smarter calls and better informed decisions during a hunt. I bet you are wondering, isn't this something only complex and a specialized solution can handle? In a bigger picture, yes. But here is the thing. We are already doing many of these steps in every threat hunting, perhaps on a smaller scale. Let's put them in a simple example. You know how much I love to simplify things with the examples, right? I remote into my Ubuntu box for work. Pretty normal in IT, right? But that also makes it a target. So I keep an eye on system logs, user accounts, login attempts, running processes, a scheduled task, and, of course, the most challenging of all, network traffic, to check for any signs of trouble. Capturing everything non-stop is a data nightmare. Massive volume, huge storage, heavy processing. For my use case, sampling is the smarter move. Yes, I might miss a few details, but with a smart timing and a bit of luck, it works pretty well. Here's what I did. I grabbed network traffic snapshots using TCP dump at different intervals, and now I'm sitting with two files, which are the base inputs for everything we do next. Next step, quick validation. First, I want to make sure that files aren't empty and that nothing looks broken or incomplete. The head command is a quick way to inspect the first few lines and confirm the capture is intact and useful for analysis. We could go deeper, but for this demo, this is enough to move forward. Now we are good to hunt. There are many ways to cut unnecessary data and focus on traffic that's more likely to indicate potential threats. For this example, I'm focusing on TCP traffic first, because most of the services attackers love to abuse run on TCP. This is what I'm going to do. Filter the original PCAP files to capture only TCP traffic. Then remove duplicates to clean it up even more. And finally, merge them into a single file. Putting all the capture files together gives us a full picture over time. And most importantly, we don't have to keep jumping between files. Turning PCAP into text, CSV, or JSON makes it super flexible to filter, analyze, and play with the data however we want. Make visualization, or leverage machine learning to find anomalies. With T-Shark, we can export packet details as a text or extract only the fields that we actually need. But it doesn't stop there. We can add labels and enrich the data to give it more context. For example, tagging IP using threat intel feeds. That's the basic. We can go further by enriching data using patterns and profiles, helping us flag high-risk users, high-value assets, and any deviation from the baseline. That is how I go from a raw network traffic to a fully prepared dataset ready for analysis, all with the simple Linux commands and utilities. Why Linux? Well, open source, full control and flexibility, plus great compatibility with tons of security tools, many of them already pre-installed on popular distros. One more thing, Linux shells give us a rich set of built-in commands and utilities that works really well with scripting languages. Let's look at a few essential commands every threat hunter should know. These commands are powerful and flexible enough to handle files or live streams, so we can analyze data in real time or after the fact. Using pipes, we can chain everything together without messy intermediate files. Let's continue the example. We have got our data ready in three formats: a combined TCP-only PCAP, CSV, and text file. There are a lot of ways to start hunting, and one of them is simply looking at protocol statistics to see which ones show up the most. Anything standing out? See that? SSH is way up. That spike in SSH traffic screams closer inspection. SSH makes remote access easy, and that's exactly why attackers love it. Let's zoom in into SSH traffic over port 22 and pull the top IPs. These two IPs are unusually busy over SSH. Time to check the logs and maybe bring in the FIR. Oh yeah, time to call the FIR team. These commands work perfectly here because the SSH logs are well structured. In real investigation, everything is messy, different formats and different sources. That's where regex is helpful to find patterns and keywords in the mess. Regex is a powerful way to search and work with text across all kinds of data using patterns instead of exact matches. You tell what you want and regex finds it wherever it shows up. Imagine searching for dates written in multiple formats. A single regex can find them all. Build the regex once, then run it across massive datasets. Same rules every time. It doesn't get tired and it doesn't miss things because of format changes or human errors. Here are some handy examples and resources to learn and practice regex. Imagine taking regex and pairing it with logic, loops, and file handling. Logic decides what happens to the data. Loops handle repetition. That's the real power of scripting. Threat hunting is all about digging into loads of data. A bit of coding can go a long way in automating repetitive tasks, speeding up analysis, and tailoring tools. Bash, Python, PowerShell, Perl, Go, no need to pick a side. Use whatever works best for the job. Grab your rubber duck. Time to code a Python script to watch SSH log for signs of brute force attack. Putting everything together helps us to see what's going on. Sounds simple? Not really. There's still a ton of raw text to process. We are wired to notice visual patterns. So why dig through endless logs when visuals make it instantly clear? For example, in our SSH case, reading the logs shows hundreds of login atoms. Hard to follow, but a simple chart? That's your attacker, instantly visible. Have you noticed? All the visuals we just saw had one thing in common: a central idea guiding them. An educated guess that directs the investigation. That's the hunting hypothesis. Stay tuned. I think this is so cute to involve in cyber attacks. I need someone darker to have a more serious talk.